We're solving problem 24 from the spring 2021 AMC12B. Let ABCD be a parallelogram with an area of 15. Points P and Q are the projections of A and C respectively onto the line BD. And points R and S are the projections of B and D respectively onto the line AC. See the figure, which also shows the relative locations of these points. Suppose P cube is 6 and RS is 8. And let D denote the length of BD, the longer diagonal of ABCD. Then D squared can be written in the form M plus N root P, where M, N, and P are positive integers, and P is not divisible by the square of any prime. What is M plus N plus P? So here we have the figure, and for simplicity, let's call this point in the middle X. It then goes that the distance from xq is equal to xp, which is equal to 3. Since the problem states that the total segment of p cube is 6, you divide that by 2 to get the two equal segments, which is 3. And then similarly, it also gives you that the segments xr is equal to segment xs, which is equal to 4 units. And then, since on the problem there are a lot of angles drawn, we know that angle APB is equal to angle ARB, and this is 90 degrees. Now, since these are both 90 degrees, this proves that this figure ARPB is cyclic. And well, so then if it's cyclic, we can write that XA times XR is equal to XB times XP. So when you divide all of them, you will get a sort of equating of fractions. So XA over XB is equal to XP over XR, which is 3/4. Then you can say that the segments XA, this can be represented as 3 times a variable x, where this is 3 of something, and similarly for XB, this would be 4 of an x. So then, when we look at this triangle APX, we can use the Pythagorean theorem to find length AP. Why do we want to find the length AP? Because if we want to find the total area of ABCD, ABCD is simply equal to 2 times the triangles ABD, which you can just break this even further down into just BD times AP to get a rectangle. So we want to find AP in terms of x and BD in terms of x. So we use the Pythagorean theorem to get that AP is equal to the diagonal AX is 3x squared minus the other length XP, which is 3 squared square rooted. So then we can just factor out the square 3 in both terms to get that length AP is equal to 3 root x squared minus 1. So we have one of our lengths now, and what we can do here with is, well, now all we have to do is find the total length of BD. Well, let's look at XB. We set it earlier to 4 times x, so simply the total length of BD would be twice that amount, so 8x. So therefore, the total area would be equal to AP, which is 3 root x squared minus 1 times 8x. And the problem says that the area of ABCD is 15. So we set this to 15. So then we just multiply this across to get 24x root x squared minus 1 is 15. Now, when you like square all of this out, the x's will multiply, and then you will get an equation for x squared. So after doing all the work and multiplying these things out, you will get that x squared is 1/2 plus root 41 over 8. Well, then how does this help us? If we have this value of x squared, and we want the total length of the distance d squared, we know that its square rooted is 4x. So you have to multiply by 2 and then square the whole thing. So essentially you want 8x and then square all of this. This becomes 64x squared, which is 64 times 1/2 plus root 41 over 8. The terms cancel out to be 32 plus 8 root 41. So we want the sums of all these numbers. So 32 plus 8 plus 41 is 81, our answer for this problem.